Fluid mechanics. A study of fluid either at rest, fluid statics, or in motion, fluid dynamics, and the subsequent effects of the fluid on the boundary. We are going to study about to what extent does the OBTA helps to prevent wax deposition problem in comparison with the conventional methods. Wax deposition problem. Paraffin wax continues to be a leading problem area in the production and transportation of crude oil. Severe plugging from the deposition. Production loss and replacement of pipelines. My presentation focuses on a comparison between the conventional method, pigging, and OBTA.
Paraffin wax is a hydrocarbon component that consists of many normal alkanes, cycloalkanes, isoalkanes, and a very small amount of aromatic material. Molecular weights are usually less than 450, and at 210 Fahrenheit, the viscosity will be less than 6 centisols. The lighter components in the crude oil keep the heavy components in solution. If the temperature is greatly reduced, the solubility will be decreased as well, to cause precipitation in the pipeline. The presence of wax crystals changes the behavior from Newtonian to non-Newtonian fluid. The wax crystals usually lead to higher viscosity with increased energy for pumping. In addition, if the oil is cooled during transportation, the wax crystals easily deposited in the cooler wall.
Pigging is a technique often used to clean out the debris and other impurities remaining inside the pipeline, so that the goals of cleaning pipeline, reducing pressure drop, and increasing efficiency of transportation can be reached.
Here we have an analogy of pigging. A cleaning pig is inserted at the starting of the pipeline, and it is pumped all the way to the second end. It scrubs the debris and the wax in the pipeline. The pig in general must be able to provide sufficient force on the pipe wall. Sphere-shaped pig will not be able to remove wax deposition. Frequency must be sufficient to prevent any excessive build-up of wax deposit. An estimate build-up of 1 mm to 4 mm between pigging runs, as fixed as a thumb. Pig scrubs off the wax deposit in the pipe walls. The red color is the cleaning pig. As it travels down the pipeline, more wax will be scrubbed off, thus creating a need for increased energy for pumping.
It is a relatively new mixing technology and offers more uniform mixing and particle suspension than traditional reactors.
The OBTA generates mixing that is mostly done by turbulence, in which the larger eddies repeatedly move parts of one batch of liquid into the midst of the batch of liquid.
This is the model apparatus of OBTA. It either oxidates the fluid at the base or oxidates the baffles at the top. Baffles obstruct the flow of fluid and prevent the whole fluid mass from rotating.
At low wax concentration, the oscillatory motion significantly reduces the percentage of wax deposition without any solvent or enzyme or wax inhibitor. It prevents 100% of wax deposition from happening. At 10% wax concentration, the Albermi exponents experience a step change increase in the presence of oscillation in comparison of these without. These suggest the oscillatory motion has altered the growth form in reducing the wax deposition. At higher wax content, on the other hand, the introduction of oscillatory motion not only promoted wax deposition, but also speeded up the rate to achieve 100% gelation. The OBTA operates continuously without shut-in production, unlike the pigging. OBTA does not need any pumping force to operate. As wax concentration of crude oil is usually less than 20%, the detrimental effect in which OBTA promotes wax gelation at higher concentration is usually not affected.